Hi, this is Mr. Mack. This is a video on the concepts of trigonometric functions of general angles. Now, in an earlier video, we defined trigonometric functions with respect to right angles, or with respect to right triangles, and you had the memory device SOHCAHTOA. We would really like to extend this knowledge, though, to the more general idea that a trigonometric function can be found for any line segment with the initial side at the origin and the terminal side somewhere in the xy plane, where this is going to be the point xy, and this is going to be the angle theta. Now, if we were to put the right triangle in here, and also if we call the length from the origin out to the point xy r, then notice that r is equal to the square root of x squared plus y squared. That's the Pythagorean theorem. Now, we're going to define the trigonometric functions in the following way. The sine of this angle theta is going to be y over r. The cosine of this angle is going to be x over r, and the tangent of theta is going to be y over x. Now, remember, the reciprocal function of the sine of theta was the cosecant of theta. Cosecant of theta. And if it's the reciprocal of the sine of theta, obviously it's r over y, and the reciprocal function of the cosine of theta is the secant of theta, and it would obviously be r over x, and the reciprocal of the tangent of theta is the cotangent of theta, and it would be x over y. Now, these are the general definitions of the trigonometric functions with an initial side of the angle on the positive x-axis and the terminal side of the angle being the hypotenuse of a right triangle. The thing that this does for us is when our angle is what we call a quadrantal angle. Now, in other words, if you have an angle of 0 degrees, if your terminal ray has an angle of 0 degrees, then there is no SOHCAHTOA for you. So how do you find the sine, cosine, tangent, cosecant, secant, and cotangent, and so forth? So if we have a 0 degree angle, notice this is the point xy, and this is the distance r. Now, with a 0 degree angle, obviously y is 0. So when we get the sine of 0 degrees, we get 0 over r, which is 0. The cosine of 0 degrees is r over r, because the x value of the point here is the same as the distance from the origin to it. So we get r over r for cosine of 0, and that would be 1. And the tangent of 0 degrees would be y over x, which is 0 over r, which is 0. Now, the cosecant of theta, of 0, cosecant of 0 degrees turns out to be r over 0, which is undefined. The secant of 0 degrees is the reciprocal of 1, r over r, which is still 1, and the cotangent of 0 degrees turns out to be r over 0 again, which ends up being undefined. So, in other words, this allows us to have assigned values for 0 degrees. Now, the same thing happens for 90 degrees, 180 degrees, 270 degrees, 360 degrees, etc., etc., etc. So these definitions right here are the generally accepted formal definitions for sine, cosine, tangent, cosecant, secant, and cotangent of theta. And the quadrantal angles are angles that are multiples of 90 degrees. In other words, starting with 0, 0 is a multiple of anything, and then 90, 180, 270, 360, negative 90, negative 180, and so forth like that. And you can play with those some and get those values. Now, the next thing that we need to talk about is reference angles. Now, oh, well, maybe before reference angles, let's spend a little time on Sigyns. Now, see, this is, now that we're in trig, this is the sine function, and usually we abbreviate it SIN, okay? And so when we see SIN, we say sine. But before we had trig functions, the word sine meant something else. Now, it gets a little confusing if a teacher says something, now the sine of the sine. You might say, well, what on earth do you mean by that? And we're talking about the this of this, for example. And so what I'm going to try to do is I'm going to try to pronounce this one as Sigyn. So when I mean the positive or negative sign, I'm going to say the Sigyn of this so that we don't get confused between sines and sines. All right, now let's take a look at our definitions again and terminal ray. Now let's imagine we have our terminal ray in the first quadrant, and this is our angle theta. Now the Sigyn of the, let's see, sine, cosine, tan, cotan, secant, cosecant. In the first quadrant, they're all positive because x, y, and r are all positive. Now, in the second quadrant, let's see if I can get this over to the second quadrant somehow. In the second quadrant, notice that y is still positive, and r will always be positive. So in the second quadrant, the Sigyn of the sine is positive. The Sigyn of the cosine is negative. Now, the tangent is y over x. In the second quadrant, y is positive, x is negative. So the Sigyn of the tangent in the second quadrant will be negative. Now, the cotangent is x over y. Again, x being negative, y being positive in the second quadrant. The Sigyn of the cotangent is negative. Now, the secant is the reciprocal of the cosine. Cosine is x over r, so the secant is going to be r over x. R always positive, x being negative, the secant is going to be negative, and the cosecant is going to be positive. Now, there is another way to look at this also. You see, these three functions are the reciprocal functions, reciprocal of the tangent, reciprocal of the cosine, reciprocal of the sine. And notice whatever Sigyn the sine is, its reciprocal is the same Sigyn. Whatever Sigyn the cosine is, its reciprocal is the same Sigyn. And whatever Sigyn the tangent is, its reciprocal is also the same Sigyn. Because the reciprocal of a positive number is positive, the reciprocal of a negative number is negative. Now, if we go down to the third quadrant, let's just move r down here and extend theta a little bit farther. Now, notice that both, oh, and x and y have to come down here. There we go. In the third quadrant, both x and y are negative because we're going left and down. So and I'm running out of room here. Let's take all of this, make it a little bit smaller, and then we'll move all of this over a little bit. There we go. So now we can do third quadrant. Now in the third quadrant, y over r, y is negative, r is positive, so the secant of the sine is negative. The cosine is x over r, x is negative, r is positive, so the cosine in the third quadrant is negative. The tangent in the third quadrant is y over x. Now y is negative, x is negative. Negative over negative is positive. So the cotangent will be positive, the secant will be negative, and the cosecant will be negative. Because again, the same things occur with the reciprocal functions. And finally, in the fourth quadrant, in the fourth quadrant, one more time, rotate this around and put it back here, move r over here, and move xy over here. There we go. Now, oh yeah, and theta goes around to here. All right. Now in the fourth quadrant, x is positive and y is negative. So that means that the secant of the sine will be negative. The secant of the cosine will be positive. The secant of the tangent, y over x, y is negative, x is positive, is negative. And then, of course, the cotangent will be negative, the secant will be positive, and the cosecant will be negative, because once again, this reciprocal thing is working for us. And so this is a little chart of the secants of the trigonometric functions when the terminal angle is in the first, second, third, or fourth quadrant. But now, if you'll notice that the ratios of these trigonometric functions are defined in the order of ratios of either x and y, or x and r, or y and r. And so these numbers repeat except for their secants through the three quadrants. So if you would look at this, an angle of theta here would have an x and a y. Now, the angle over here, where theta was this angle, and this was like 180 minus theta, would have the same ordered pair, except x would be negative and y would be positive. And so we would get the same ratios except for the secants. And so it turns out that we like to define angles by using what is called a reference angle. Now, this is a very, very important definition. You should learn and memorize this definition and then meditate on it. Now, a reference angle, let me do this again here, sorry. Reference angle. A reference angle is, definition here, the positive acute angle that the terminal side of the angle makes with the x-axis. A lot of times we refer to the reference angle as theta sub ref, or in other words, the reference angle for any angle theta. Now, if you memorize and make this definition part of yourself, then the chart that they include as to how you find the reference angle in the different quadrants is just totally done away with. And all you need to do is draw yourself a little picture and look at it, and you won't have any trouble. If that is not your way, this is a really, really advantageous time to make it your way. But if it turns out that this is not your way, then there is a chart that gives you what to do to find the reference angle in the 4 different quadrants. And as we do multiple rotations of that terminal angle, it gets more and more confusing if you want to use the chart. But I'm telling you, if you do it that way, it is self-inflicted. So let's take a look at what we mean when we say find the reference angle. Okay, so let's start with a simple one. Find theta ref for theta equals, let's say 130 degrees. Now, definition. The reference angle is the positive acute angle that the terminal side of the angle makes with the x-axis. So, here's an xy axis. Here is the initial side of the angle. And if it's 130 degrees, 130 degrees goes over here someplace. Let's just put it right there. And this will be 130 degrees. So this is theta. Now, the positive acute angle that the terminal side of the ray makes with the x-axis. Now, here is the terminal side of the angle, the terminal ray. And this angle right here, I'm going to draw it in blue, I guess. This is going to be theta ref in this particular case. Now, if you look at this picture, it should be obvious that theta ref is equal to 180 degrees minus theta. Now, they will give you a chart that says if you're in the second quadrant, then the reference angle is the measure is 180 minus the measure of the angle. Now, why is this confusing? Well, let's take a look at another one. Let's let theta be equal to 255 degrees. Okay, now the initial ray is going to be the positive x-axis, and 255 degrees is more than 180, less than 270. So it'll be somewhere over here. And here will be the terminal side. Now, this whole angle right here, 255 degrees, is theta. Now, here is the terminal ray of the angle right here. Now, the positive acute angle that this ray makes with the x-axis is this angle right here. So this would be theta ref. Now, you should be able to see that theta ref in this particular case is theta minus 180. See, theta minus 180 gives you theta ref, okay? And this is what you do in the third quadrant. Now that's in the chart as well. But if you're just remembering the definition, the positive acute angle the terminal ray makes with the x-axis, and you draw yourself a little picture, it should be pretty obvious to you what you do, okay? Let's try one other one here. Let's let theta be equal to 312 degrees, okay? And we're supposed to find theta ref. All right, now, here again is our xy axis. Our initial ray will be along the positive x-axis, and theta is 312 degrees. Now that's more than 270, which is three quarters of the way around, less than 360. So the terminal side will be here someplace, and this is theta equals 312. Now, theta ref is the positive acute angle that the terminal ray makes with the x-axis. So this would be theta ref right here. Now, again, if you look at this, theta ref would be 360 minus theta. So in the fourth quadrant, theta ref is equal to 360 minus theta, or in this case, 360 minus 312, or 48 degrees. Okay. Now, the reference angles are very important because let's just take this last one here as an example. If you were asked to find the sine of 312 degrees, okay, what you could do is you could say, all right, now the sine in the fourth quadrant is negative. So the sine of 312 degrees would be the negative of the sine of theta ref, which is 48 degrees. So the sine of 312 degrees would be the same as the negative sine of 48 degrees. Now, it used to be that this was extremely important because we didn't have calculators and you had to look up the the value of the sine of an angle in a table, and usually what they would do is they would give you the angle, the sines, cosines, and tangents of angles in the first quadrant, and then what you had to do is you had to come up with the reference angle and the Sigyn of that particular trigonometric function and then use the tables. There are other reasons why this is important too. So this is the idea of the reference angle, and this is how the reference angles are used. We use it in conjunction with this chart on Sigyns of the trig functions, and then this definition of the reference angle, and so then the sine of any angle, or the cosine or tangent, or even secant, cosecant, cotangent of any angle is the Sigyn of that trigonometric function in that quadrant times the trigonometric function that you have over here of the reference angle. And that is kind of an important thing to know. All right, that is a pretty complete coverage of the chapter 13, section 3. There is one other thing I see in here, and that is the sines, cosines, tangents, and so forth of the special angles. Now, I talked about those already in a preceding video using the special triangles 30 degrees, 45 degrees, 60 degrees. And in this definition, they are exactly the same. So I'm not going to go through that again. If you need more help on that, go back and find that other video. I think it was 13.2 that did that. And look at that again. And that concludes the video for 13.3.